A very basic question, that why heat flows only from hot to cold body in a natural manner? Why not in the reverse direction? Though first law is not violated in either case. This is the limitation of first law, that it serves the purpose of balance sheet of energy transaction, but is unable to provide the direction of transaction. In other words, first law fails to give a criteria for spontaneity. By virtue of experience, people had set energy E or enthalpy H as the oldest criteria for the occurrence of a spontaneous process. We still use it most of the time, that lower is the energy, more is the stability, and hence a spontaneous process must go itself in the direction which leads to a decrease in the energy of the system. But this criteria is not free from exceptions. One simple exception is evaporation of a liquid. Obviously, scientific world required a new criteria which was provided by second law of thermodynamics in the form of entropy S. This property was introduced by Clausius. Now we come to different statements of second law of thermodynamics. Number one, heat cannot of itself pass from a colder body to hotter body without the intervention of external work. Number two, all the spontaneous processes are irreversible in nature. 3. The entropy of universe is always increasing in the course of every spontaneous process and remains unchanged in an equilibrium state. There are many more statements, but from chemistry point of view, these are sufficient for us. Let us now see mathematical form of second law. If a system absorbs some heat Q reversibly and isothermally during a process at constant temperature Tk, then a thermodynamic property entropy S increases such that delta S equal to Q reversible upon T. However, for smaller amounts we can write roughly as dQ is equal to TdS. Thus, if Q is expressed in joules and temperature in Kelvin, then the entropy change is given in unit Joule Kelvin inverse. Obviously, for 1 mole, it would be Joule Kelvin inverse mole inverse. Remember, entropy, like other thermodynamic functions, for example E and H, is a state function. Now before we go for some mathematical calculations for entropy change, we must understand the significance of entropy. Significance of entropy S. A. Entropy as a measure of disorder. It is a matter of common experience that a system left to itself will gradually pass into a state of equilibrium. The state of equilibrium really means a state of maximum disorder or chaos. For example, if we let loose a quantity of yellowish green glowing gas at a corner of the floor of the room. The gas, though heavy, would spread in all directions until it would be most chaotically distributed into the entire room, and the equilibrium would be reached. Consider some crystals of pure sodium chloride. As we have seen in the chapter on solid state, in the lattice of sodium chloride, sodium ions and chloride ions are arranged in an octahedral manner. That is, each sodium ion is octahedrally surrounded by 6 chloride ions and vice versa. Thus, there appears to be an orderly arrangement of particles in sodium chloride crystals. In terms of entropy, we will say that entropy of a crystalline solid is very small because more is the disorder, more is the entropy. Now when these crystals are put in water, what happens? The crystals are no longer visible after some time. They get dissolved to form solution of sodium chloride.